This is solar PV based mobile battery charger. It consists of solar panel. Here you can choose solar panel as secure. We can I open this model. Here you can change this one parallel string. If you are use single model, the power rating will be 9 watts. So recently you can see the battery charger rating, normal battery charger rating. The top comes with 50 watts, 50 watts, 30 watts, and 20 watts. Based upon the things, we can change the rating also by making that parallel string numbers. If you want 20 watts, near 20 watts charger controller for that battery by using solar PV, then you can change this value to 2. If you change this value to 2 means already the single model has 9 watts. If we change to 2 means you will get 18 watt solar panel power. That means you are going to combine 2 panel in parallel. That's why the power rating going to be increase. Here I choose parallel string equal to 3. I send one model. In that model, you can see that the parallel string value is 1. So you can change this value also. So if you change this value 1, for example, I'm going to change this value to 1. Again, first I stop this simulation. Initially, I'm going to use one series string, one parallel string model. Then the power rating of that panel is 9 watts. The maximum current it can supply is 0.75, and then voltage will be 12 volt. So you can see the variation of this solar panel voltage and current here, and then you can see the variation of battery voltage and current here. And then here in between the solar panel and battery, I have used to buck converter. So normally and solar that means battery mobile phone having lithium-ion battery with a rating of 5 volt or 3.3 volt. Here I'm going to consider 5 volt lithium-ion battery with 6000 mAh rated capacity battery. And initial state of charge of the battery is 50%. I'm going to consider. So this battery going to be charged by means of the solar PV panel. Now I am going to simulate this one. We can see that in the panel voltage is around 12 volt. The current is from the solar panel is around 0.72. Here you can see that the panel load, that means battery voltage is around 5.43. That panel voltage, nominal voltage is 5 volt, and then it can be charged up to 5.8 volt. And then this operating range for that panel, that means 3.75 to 5.8 volt. If it is 100%, that voltage in that battery is around 5.81. If it is 0%, means the voltage is around 3.75. And then the battery can discharge maximum current of 2.6 amps. So now you can see that the current given for that charging current is around minus 1.4, because Y is minus, the current direction will be is in this direction. That's why the battery current is minus. If it is minus, the battery charging condition. And also you can see the variation of that PV voltage current. This is PV voltage, PV current, and the PV power. This is battery voltage, a battery current, charging current, and the state of charge. Initially, is a state of charge will be 50%. Every second, the charge will be increasing. This charging depends upon that current, how much current, how much charging current is given to that battery. So this is depends upon the charging current. Here I simulated in between 0 to 60 seconds only. We can finally you will see that variation from 0 to 60 degree. So you can check the initially that at 0 second the battery charge around 50%. After 60 seconds you will get some charge. Based upon this value you can calculate for what's the charging charge percentage after 1 hour. That means so this is for 60 seconds, that means 1 minute. You can find out the slope, that means in between this 0 to 60. After just you have to multiply it with that 60, you will get 1 hour charging percentage. So that's why you can check the charging time, charging level for 1 hour, 2 hours, 3 hours. And also here this charging slope is depends upon the charging current, that means from the solar panel power. So next you can change the solar panel power rating also. By changing the solar power rating, you can see the variation of charging current, and also you can see the variation of charging level of the battery. Depends upon the charging current also. So for that I'm going to make the solar panel rating. That means I'm going to use 50 watts panel. So for that I'm going to multiply it with 5. If I mean 45 watts panel, so I'm going to use 45 watts panel and then I'm going to simulate this model. Now I used 40 watts panel. Now you can see the panel voltage and then you can see the panel current. Before it value is around only 0.7. Now you can see that panel is supplying the current of around 3.8 amps. So this is, you can see the PV power will be around 45 watts. This is charging voltage of the battery. This is a charging current. Now you can see the charging current is around -6. And also you can see the variation of charging level of the SOC when compared to we are using 9 watts. When you use 9 watts panel, the charging slope will be very charging time or charging of the battery is very slow. When you are going to use 40 watts panel, the charging of that battery is very high. Just you can compare the slope of both 9 watts panel with battery and then 45 watts panel with battery. So we get some idea. So I'm going to be simulate this model up to 60 seconds. So we will check the process. Now you can see that with the 30-second SOC, state of charge of battery change from 50 to 51 percentage. That means within 30 seconds it will charge 1 percentage. That means within 1 minute it will going to be charged 2 percentage. That means we are going to charge the battery by using this 45 watts panel with that DC-DC converter with the MPPT algorithm. You can charge the battery from 0% to 100% around 50 minutes. Within 50 minutes, you can charge the battery by using this model. This is P&O algorithm. Here we are measuring that voltage and current of the PV panel. After that, we are going to calculate the change in power and then change in voltage, and then you have to check the change in power level. If change in power is greater than 0, it's going to allow this one. If change in power is not less than, so greater than 0, and then it's going to allow this logic. So here you are going to check the condition, a change in voltage. If change in voltage is greater than 0, it's going to decrease the duty cycle by the amount of del T. When the change in voltage is less than 0, it's going to allow and it increase the duty cycle by the amount of del T. The same case going to be applied here in inverse direction. That means this condition is true, that means it increase the duty cycle. If condition is false, it decrease the duty cycle. By means of this, we are going to apply the P&O algorithm. Finally, we will get the duty cycle. Here we are measuring the parameter of that battery. That means state of charge and battery maximum charging voltage. Based upon this, if SOC is less than 100 and then the battery voltage is less than or equal to maximum charging voltage, then it allow that PWM signal to the converter to charge the battery. So this also going to be given to the buck converter. So this converter is transfer the power from that solar panel to battery to charge the battery. So this is the working of that solar PV based mobile battery charger. Thank you.